So this tutorial on exponents deals with solving exponential equations. Now, when we solve exponential equations, we use this very important exponential law that says if a to the power of m equals a to the power of n, then m will equal n. In other words, when the bases are the same, in this case the base is a on both sides, so when the bases are the same, the powers must be equal. So in the first equation here, we need to solve for x, and we are told that 2 to the x equals 128. We want to be able to use this exponential law, so we want to make the bases the same on both sides. The base is 2 on the left-hand side, so we want a base of 2 on the right-hand side as well. And using prime factors, we know that 2 to the power x will equal 2 to the power 7. In other words, 128 is 2 to the power 7 using prime factors. Now the bases are the same on both sides, and that means by this exponential law, the powers must be equal. In other words, x must equal 7. Let's solve the second equation here. We have 3 to the power of x times 3 to the power of 9 equals 3 to the power of 13. We're first going to use this exponential law and simplify the left-hand side. So this law that says a to the power m times a to the power n equals a to the power m plus n. In other words, when we multiply two numbers and the bases are the same, we can add the powers. So applying this law to the left-hand side of this equation, 3 to the x times 3 to the 9 will be 3 to the x plus 9. So adding the powers. Now we see that the bases are the same on both sides of the equation. So that means that the powers must be equal. So x plus 9 must equal 13. And we solve this equation. So x equals 13 minus 9, which is 4. Let's look at number 3. We have 2 to the 9 divided by 2 to the x equals 4. We're first going to simplify the left-hand side by using the following exponential law. A to the power m divided by a to the power n equals a to the power m minus n. So applying this law on the left-hand side of the equation, we see we have 2 to the 9 divided by 2 to the x equals 4. So because the bases are the same, we can use this exponential law and subtract the powers. So it's going to be 2 to the 9 minus x equals 4. Now we want the bases to be the same on both sides. So we're going to make the bases the same by writing 4 as 2 squared using prime factors. Now the bases are the same, and that means the powers must be equal. So 9 minus x must equal 2. And we can solve for x in this equation. Negative x equals 2 minus 9, which is negative 7. So negative x equals negative 7. And we can divide through by negative 1 here, and we find x equals 7. Then in number 4, we have 3 to the power of 2p minus 3 equals 81. We want the bases to be the same on both sides. So we're going to use prime factors on the right-hand side. So on the left-hand side, we have 3 to the power of 2p minus 3. And using prime factors of 81, 81 can be written as 3 to the power of 4. Now the bases are the same on both sides, and that means the powers must be equal. So 2p minus 3 must equal 4. And we solve for p in this equation. So 2p equals 4 plus 3, which is 7. and dividing 2 into the right-hand side, p is 7 over 2. So here we have 4 to the power of t equals 32. We want the bases to be the same on both sides. So 4 we're going to write as 2 squared. Using prime factors, so on the left-hand side here, we have 2 squared all to the power of t. On the right-hand side, using prime factors, 32 is 2 to the power of 5. Now we're going to simplify the left-hand side. Now remember this exponential law. A to the power m all to the power n equals a to the power of m times n, or a to the power of mn. So when we have brackets, we can multiply the powers. So applying this law then to the left-hand side of the equation here, because we have brackets, we can multiply the powers. So 2 to the power of 2t equals 2 to the power of 5. Now the bases are the same on both sides of the equation, and that means the powers must be equal. So that means that 2t equals 5, or must equal 5. And in solving for t is equal to 5 over 2. Then in number 6, we have 32 to the power of x equals 2. Once again, we want to make the bases the same on both sides. Using prime factors on the left-hand side, we know that 32 is 2 to the power of 5. So on the left-hand side, we have 2 to the power of 5 all to the power of x. And this is equal to 2. Now, on the left-hand side here, we can apply this exponential law. Because we have brackets, we can multiply out the powers. So 2 to the power of 5 times x, so 2 to the power of 5x equals 2. Now, there's a 1 here as a power of 2 that we don't write. Since the bases are the same, we can make the powers equal. In other words, 5x will equal 1. And solving for x is 1 over 5. Then in number 7, we have 2 to the power of r equals 1 over 16. We can rewrite the 16 using prime factors. We know that 16 is 2 to the power of 4. Now, remember that we want the bases to be the same on both sides of the equation. Now we're going to use this exponential law. A to the negative m equals 1 over a to the positive m. So we're actually going to use the reverse of this law on the right-hand side here. So then on the right-hand side, 1 over 2 to the 4 is the equivalent of 1 over a to the m. And we want to write it in this form, a to the negative m. So it's going to be 2 to the negative 4 using this exponential law. Now the bases are the same on both sides. So that means the powers must be equal. So r must equal negative 4. Then in number 8, we have 5 to the q equals 1 over 125. We're first going to rewrite the right-hand side using prime factors. 125 is 5 cubed. So we have 5 to the q equals 1 over 5 cubed. We want the bases to be the same. So we can rewrite the right-hand side here by using this exponential law. So 1 over 5 cubed is 5 to the negative 3. Now the bases are the same, and that means the powers must be equal. So q must equal negative 3. Here we have 4 to the x equals 1 over 64. We can rewrite the right-hand side. We know that 64 is 4 cubed. Remember that we want the bases to be the same on both sides. We can rewrite the right-hand side here as 4 to the negative 3. Now the bases are the same on both sides of the equation, and that means the powers must be equal. So x equals negative 3. Then in number 10, we have a half to the y equals 64. we're going to rewrite the left-hand side of the equation because we want the basis to be the same. So to rewrite the left-hand side, we use this exponential law again. A to the negative m is 1 over a to the positive m. So a half here, we can then write as 2 to the negative 1. So 2 to the negative 1 all to the y equals 64. Now 64, we can use prime factors of 64. We know that 64 is 2 to the power of 6. So we rewrite the left-hand side using this exponential law. We rewrite the left-hand side with a negative power. Now we have brackets, so we can multiply the powers. Negative 1 times y is negative y. And the bases are the same now on both sides of the equation. That means that the powers must be equal. So negative y must equal 6. And dividing the negative 1 here into the right-hand side, y will equal negative 6. Then in number 11, we have 9 to the x equals 3 to the x plus 2. We want the basis to be the same. So we're going to rewrite the left-hand side. 9 is 3 squared using prime factors. So we have 3 squared all to the x equals the right-hand side. Because we have brackets on the left-hand side, we can multiply out the powers. 2 times x is 2x. Now the bases are the same on both sides of the equation. So that means the powers must be equal. So 2x must equal x plus 2. And we can solve this equation. The x on the right-hand side here we can bring to the left-hand side. So 2x minus x equals 2. 2x minus x, of course, is 1x. So x equals 2. Then in number 12, we have 5 to the x plus 1 equals 25 to the x. We want the basis to be the same. So we're going to rewrite the right-hand side using prime factors. We know that 25 is 5 squared. Now we have brackets, so we can multiply the powers. So 2 times x is 2x. So we have 5 to the x plus 1 equals 5 to the 2x. So the bases are the same on both sides of the equation. And that means the powers must be equal. So x plus 1 must equal 2x. We can solve this equation. We can bring the 2x to the left-hand side. So x minus 2x on the left-hand side here. And we can take the 1 to the right-hand side. So it becomes negative 1. Then x minus 2x is negative x. We can get rid of the negative on the left-hand side here. There's a negative 1 next to the x on the left-hand side. So we can divide it into the right-hand side. So negative 1 divided by negative 1 is positive 1. Here's a fairly tricky one to solve. We can simplify the left-hand side. And we're going to rewrite the 1 over 9 as 1 over 3 squared. Remember that we want the bases to be the same on both sides of the equation. We can simplify this part. We're going to rewrite 1 over 3 squared as 3 to the negative 2. We have brackets here, so we can multiply the powers. So negative 2 times 4 is negative 8. And negative 2 times negative 3x is positive 6x. We can simplify the left-hand side even further. We are multiplying two numbers where the bases are the same. So we can add the powers. So 3x plus 6x is 9x. And then, of course, we have the minus 8. On the right-hand side here, 3 is the same as 3 to the power of 1. So there's a 1 that we don't write. Now the bases are the same. and that means the powers must be equal. So 9x minus 8 must equal 1. And we can solve for x in this equation. 9x will equal 1 plus 8, so 9. And we can solve for x by dividing this 9 into the right-hand side. So 9 divided by 9 is 1. So in question 1a here, we have to solve this equation. 3 to the t equals the fifth root of 3. In solving this equation, we're going to use this exponential law. The nth root of a equals a to the 1 over n. In other words, we can rewrite a surd in exponential form by using this law. So we're going to apply this law to the right-hand side of the equation. So we have 3 to the t equals 3 to the 1 over 5, 1 over n. Now the bases are the same, so the powers must be equal. In other words, t must equal 1 over 5. Let's look at b. Once again, we can rewrite the right-hand side as 2 to the 1 over 3, using the preceding law. So 2 to the x equals 2 to the 1 over 3. The bases are the same, so the powers must be equal. Let's look at c. We have 2p to the power of a third equals 6. We can first get rid of the 2 on the left-hand side by dividing it into the right-hand side. So p to the 1 over 3 equals 6 divided by 2, which is 3. We want to isolate the p on the left-hand side. In other words, we want to get rid of the power here. And the way we can do that is by raising both sides to the power of 3. Then on the left-hand side, we have brackets so we can multiply the powers. A third times 3 is 1. So we end up with p to the 1, or just p on the left-hand side. Then on the right-hand side, we have 3 cubed, which is 27. So here we have a really tricky question. It says given that the cube root of y squared equals the 6th root of x, and y equals the nth root of x, find the value of n. So we're going to work with this equation. So we have the cube root of y squared equals the 6th root of x. We want to get rid of the surds here. And we can use on the left-hand side, we can use this law of surds. The nth root of a to the power of m is a to the power of m over n. We can apply this law to the left-hand side here. So the cube root of y squared will equal y to the power of 2 over 3, m over n. Then, getting rid of the surd on the right-hand side here, we can use this law of surds. The nth root of a equals a to the 1 over n. So we can use this law on the right-hand side here. The 6th root of x is x to the 1 over 6, 1 over n. We want to isolate the y on the left-hand side of this equation. In other words, we want to get rid of the power here. And we can do so by raising both sides of the equation to the power of the reciprocal of 2 over 3. In other words, to the power of 3 over 2. So we raise both sides to the power of 3 over 2. Then on the left-hand side, we have brackets so we can multiply the powers. 2/3 times 3 over 2 is 1. So we end up with y to the 1, or just y on the left-hand side of the equation. On the right-hand side, we can also multiply the powers. A 6 times 3 over 2 is a quarter. So we end up with x to the 1 over 4. Now, remember that we were told that y equals the nth root of x. So we can rewrite the right-hand side here as a surd. Then, using this law on the right-hand side, the nth root of a is a to the 1 over n. So x to the 1 over 4, using the reverse of this law, and rewriting this exponent as a surd, we can write it as the 4th root of x. So x to the 1 over 4 equals the 4th root of x by using the reverse of this law. But now remember that we were told that y is the nth root of x. And here we can see that y is the 4th root of x. So that means that n equals 4.